AB Calculus. This is the first lesson of Unit 7, Second Fundamental Theorem of Calculus. Let's recall what the first fundamental theorem of calculus was, and that just said that the integral from a to b of a derivative would equal the original function with the top plugged in minus the original function with the bottom plugged in. I don't know if you could see that. I'll zoom out. Okay, now there's a second fundamental theorem of calculus. It's very easy. The second fundamental theorem of calculus says, given, okay, this is going to be funny, you guys. You ready? There's lots of F's going on, and a lot of times kids go through the whole class without understanding all of these F's and capital F's and F prime. Do you see how this f of x is equal to this integral? So this is new. This is called functions defined as integrals. I'm talking while you guys write this down, okay? An integral defined as a function. So usually we just play with this, but now we're saying, nope, we're going to name this a function. It's weird, huh? But it's not hard. The math we're doing is not difficult. Okay, what does this say? Capital F prime will equal, what? Okay, we're going to take the derivative of an integral. Well, what does that mean? Well, think about what happens when you have a multiplication and you divide. What happens when you divide a multiplication? They cancel, right? Okay, what was I saying? Oh no, the bell. Okay, what if I have a 3 plus 4 minus 4? The addition and the subtraction cancel, right? They're inverse operations. What about the square root of a square? This is just not a good time to make a video. All right, we'll pause and catch up later. Okay, I'm back. What we're going to do is we're going to take the derivative of an integral. And my point over here was that inverse operations cancel each other out. So the derivative and antiderivative are inverse operations. So watch what happens. So the derivative cancels the integral. They cross each other out. And what we're going to do, it's kind of silly, this needs to be memorized, okay? We're going to plop in b, so we have f of b. Notice we're not taking an antiderivative, and we're not, because the derivative cancels the integral and leaves whatever's left over. Just like a square root cancels a square, and we're just left with x. The x didn't change, right? When we plug in the top, we also have to multiply by the derivative of the inside. What is that from? Multiplying by the derivative of the inside is from the chain rule, right? So we are combining derivatives and integration here. And then we're going to do minus, what else are we saying? We're saying top minus bottom. So we're combining two ideas here. We're going to plug in the bottom and then multiply by a prime. That's how you take a derivative of an integral. Ta-da! You ready for some examples? It's pretty easy. So you just have to read the question correctly. So make sure you see it says find f prime. Do you see that? Of the following functions. So on the left, we're going to write f prime equals. So you're declaring to the world that you're taking the derivative of an integral. So the derivative of this integral from 1 to x. Notice how we have t's in the integral, but then an x a part of our limit. So the derivative of the integral cancels, and what does our formula say? We're going to plug in. The top just plugs in. Does the 4t minus t squared, does that change? Do we change anything with the function? No. We're just going to plug in the x wherever we saw t. So that's our top. We're going to multiply by the derivative of x. What's the derivative of x? 1 minus parentheses, the bottom plugged in. What's our bottom limit? 1 minus 1 squared. And then the derivative of 1. What's the derivative of 1? 0. And then we just simplify that. 4x minus did I do something wrong here? Let's double check. 4t minus t squared. What did I forget here? 4x minus x squared. I apologize. So I have 4x minus x squared times 1 minus 4 minus 1 is 3, but times 0 is 0. So this is our final answer. Thought I had a second color here. Okay. Is that hard? Not at all. You ready? The derivative. Formula. Ready? F of b times b prime minus f of a times a prime. And I'll go over here so we can see. Okay, what's our function? Our function is cosine, and we're going to just plug in the cosine of x. So the top goes in. We multiply by the derivative of the top. So what's the derivative of x? 1 minus I keep saying the denominator plugged in. It's the lower limit is 1 times the derivative of 1, which is 0. And we have the cosine of x. And that's it. That's the final answer. So you can see that when one of your limits is a number and you're going to multiply by that number, the derivative of that number, well, the derivative of a constant is 0, so the entire term will go away. And it just makes for not very exciting math problems. And I think the problem students have is that this is so easy that they forget how to do it. So, oops, golly gee gosh. Okay, here's a shell. Ready? You see our t cubed, t cubed, t cubed. So what's going to go here? The top limit. So the top limit is x squared. And then the chain rule says we have to multiply by the derivative of the inside. So what's the derivative of x squared? 2x. Minus. So it's still top minus bottom with the chain rule. That's how we think about it. The lower limit plugged in, what's the lower limit? 1 times the derivative of 1. What's the derivative of 1? 0. So what happens to this entire back term? It goes away. And we have, what do we have here? We have x squared cubed is x to the power 6 times 2x. Can that be simplified? Yes, because we're multiplying. So it's going to be 2 times x to what power? If we have 6 here and 1 here, it's going to be the power of 7. 2x to the 7 is the final answer. All right, last example. Okay. What do we do here? We have f prime, and we leave the function alone. We replace the t with x squared. And what are we going to multiply by? The derivative of x squared, which is 2x, minus, can we do a shortcut here? We're going to plug in 1, but then we're going to multiply by the derivative of 1, which is 0. Can this be simplified? Can we simplify the square root of x squared to get x? Yes, we can. And then we have 6 times x times 2 times x. 6 times 2 is 12, and x times x is x squared. Okay, you are going to do these 3. Just be aware that right here, do you see how that says x squared? So your minus, your top minus bottom, is going to be, you're going to have a derivative instead of 0. So in our examples, they're all 0. Okay, I want you to try that, and I'm going to give you the answers in a minute later in the video. Stay tuned. It's funny, huh? Okay. If you get the U-tries correct, then you can do this practice side. It's super easy. We're going to get a little, those are the answers to the U-try. So try them first. If you get them right, go on and do these 6 for homework. But I'm going to get started with the 6 minutes I have left with the notes here. This is part 2 of the second fundamental theorem of calculus. You ready? This is fun. Picture to the right, this should look familiar. I think this is the same picture as what was on the test. Picture to the right is a graph of g, and the function f is defined to be this. You should know by now we're going to be mixing f and g and f and h and lots of different things. Let's just follow the instructions. Follow the yellow brick road. Ready? We'll go till the bell rings, till the video. I'm really sick while filming this video. So this says find f of 0. You ready? Here's f of x is equal to this mess. If I replace the x with 0, what am I going to do on the right side? So on the right side, I see -4 and 2 times x, but instead of x, what are we replacing it with? 0. So we have 0. Now, the integral of g. Is g an equation? Is it a graph? Is it a table? Picture to the right is a graph of g. This is g. So if we're integrating a graph, what does that mean? Doesn't that mean find the area? Okay, so what are we going to find the area from -4 to 0? So we know how to do this. -4 to -2. What happens to those areas? They cancel out, right? And then we need to find the area from -2 to 0. Do you remember what those are from the test or the test review? This area up here is pi. It's 1/4 pi r squared, and those 4's cancel, and that's just pi. And then this is 2. Although we're left of the y-axis, it's still positive because we're going from -4 to 0, so we're going in the positive direction, and this was negative and this is positive, so those did cancel. So then we have this area equals pi plus 2. That's all we had to do there. What does this say? Find the value of f of 2. So don't just write equals, okay? We have to write f of 2, and you need to think about this. This is f of x, so it says take my x and replace it with a 2. So we're going to do 2 times 2 is 4 of g of t, and g of, here I go, doing math without my whiteout. This is a t, okay? So from -4 to +4, what's that going to be? Well, we know that this is pi over 2, so this is also pi, and this is also 2, and then these cancel out. So what do we have there? We have, how many pi's do you see? 2 pi's? 2 pi plus 2 plus 2, 4, and that's that. All right, number 2. Can you see closely? It says find f prime. Okay, that's what we just learned. So let's find f prime. F prime will equal the derivative of this. So the derivative of this, okay, we're supposed to leave the function alone and plug in the value. So the derivative of this is going to be g of 2x times the derivative of 2x, 2, minus 0, because the derivative of -4 is 0. So this is a derivative of an integral. This is what we just learned on the first page and practiced. Now that we know that this is f prime, A says find the value of f prime of 1. F prime of 1. So f prime is now equal to this silly function, 2 times g of 2x, which is 2 times 1. So 2 times g of 2. Where do we find g of 2? What is g equal to? G is equal to the graph. So g of 2, let's see, g of 2 is this, right? The y value. So this is equal to 2 times 1, which equals 2. Isn't this fun? It's like a game. It's like a puzzle. All right, what does this say? Find the value of f prime of -2. Well, what's f prime? F prime is 2g of 2x. So we're going to plug in -2 for the x value. 2 times g of -4. And what's g of -4? What is this y value here? -1. So we have 2 times -1, which equals to -2. Fun? And we'll go on in class Next, go back and do the practice.